So I have h of x equals this quantity. I have p of x equals this quantity. Do I need any other information to use the shell method to find volume?
That small circle thing.
Now I know that's given in the problem. We'll see where that plays out here in a minute. But do I need anything else to be able to find the volume using shell method? Nope, this is enough. The formula is volume is equal to 2 pi times the antiderivative from a start to an end of p of x times h of x dx. And I know all those quantities. All right, do you know all those quantities? So heads are going up and down nodding. You know all those quantities. Volume is 2 pi. These intervals, where did we say they ranged?
Negative 1 to 1.
Negative 1 to 1. P of x we said was 2 minus x. H of x we said was 2 times the square root of 1 minus x squared. And then we have the differential dx, which is basically that width of that red vertical line that I drew up above. The small width gives you the small amount of area there to find your laminate or your cylinder. Okay?
So since they're symmetrical, we multiply by 2 and take 0 and 1?
Well, usually that's true. And what part are you telling me is symmetrical?
The right and top, well, top and right.
Top and bottom. In other words, I got a color here. That'll work. That slice there won't hit match. Slice up above. So how do I account for that? Because the question is, am I able to change my interval of integration? No. So I realize that there's a double value, but usually we use the technique, what we'll try to do is shorten our interval. You go from, say, like a 0 to a 1. But that's not going to work because out here we've got wider shells than in here. So I think we have to leave it like it is for now. Now what else are we going to do? I like the idea of distribute. And then we'll take the antiderivative. So volume is equal to 2 pi times the antiderivative from negative 1 to 1 of 4 times the square root of 1 minus x squared dx minus 2 pi times the antiderivative from negative 1 to 1 of 2x times the square root of 1 minus x squared dx. Do you understand how that went? Okay, which one of those two you want to work on first? Come on, make a choice. Left or right? Left first? Okay, we'll do left first. We have a choice. That's good. Now look at this. There's a constant that's 4 out in front. I'm going to pull that out and have 8 times 5. That leaves me with the antiderivative from negative 1 to 1 of the square root of 1 minus x squared dx. I think that looks very familiar to me. Do you see that hint that we've been talking about now? They tell me in the hint, from negative 1 to 1 of the square root of 1 minus x squared is what? Area of a semicircle. Technically what that means is, if you look at the blue stuff I had before, it's the area under this curve. That's what that antiderivative in red told us. So that probably means if we go back and think about how do I find the area of a semicircle? How do I find the area of a circle? Calculus students. Pi r squared. And if I say semicircle, so half pi times the radius squared, where the radius is 1. Would you agree? Alright. So that's that part. Well, that's not too bad. Now for the other part. If I look at this second part over here, I think if I look at 1 minus x squared and say let u equal 1 minus x squared, what is the appropriate du? So du is equal to negative 2 times x times dx. I think I've got a negative, a 2x, and a dx in that part of the problem. So I think it's going to become plus the 2 pi out in front, the antiderivative from a star spot to an in spot, unless we want to change our interval, the square root of u du. Do you agree? And so because we know how to take the antiderivative of u to the 1/2 du, what does that become? Everybody agree? 2/3 u to the 3/2 times 2 pi from the beginning to the end. So let's replace. We're almost there. This over here becomes 2 times pi times 2/3 1 minus x squared to the 3/2 evaluated between 0 and 1. This first part, I think it looks like the 2 cancel the 8 gives me 4, and pi times pi is pi squared. So that's 4 times pi squared plus that quantity. Closer. What do you think?